Lesson 3.1, numbers 8 to the end. We're going to find the slope of the curve at x equals 1. I want to do a visual perspective first. Let's put a point at 1, 3. Draw the tangent line. It says to verify the tangent line, but I'm going to start with the tangent line. So I'm doing part C first. Setting up my ruler so that it's just about grazing that dot on the curve. So we can see the slope of the tangent line is looking like about -2.5-ish. Finding it using calculus, we're going to say the limit as h goes to 0 of f of x plus h minus f at x all over h. To simplify, I'm going to make a common denominator. My common denominator is x times x plus h. My new numerator here is 3x minus 3 times the quantity of x plus h. All of this is still divided by h. Simplifying the numerator, 3x, take away 3x, cancels out. -3 times h, -3h, over x times x plus h. Dividing by h is like multiplying by the reciprocal, 1 over h. This h and this h now cancel, so I'm left with the limit as h goes to 0 of -3 over the quantity x times x plus h. At this point, because the 0 over 0, the indeterminate form is gone, I'm going to plug in h as 0. What do I know? I know my slope at the point of 1, that's what we're finding here, is going to be -3 divided by, actually I'm going to change this to x first, divided by x squared. Then I'm going to find f's derivative at 1, plug in 1 to get -3. So my slope at 1 should be about -3-ish, and we are pretty close to -3. Part B is the equation of the tangent line. I need a slope and a point. At 1, the height of the curve is 3. F prime at 1, which is my slope, is equal to -3. Y minus 3 equals slope of -3 times x minus 1. That's the equation for this tangent line right here. My next example, I'm finding the slope at 4. So again, take the ruler, line up. So I have a point at 4. Try to make it so that it's grazing the curve to model the slope at 4. Looks like the slope is pretty close to about half. I'm going to use my other definition for slope, or for the derivative, and I'm going to say the limit as x approaches, this one is the x approaching a. I have 2 square roots of x minus 4, that's the value of the function, so this is f of x minus f of a, over x minus a. I'm going to simplify this one. I'm going to pull out a 2. You don't have to pull out a 2, but I notice there are less mistakes if we have a simpler factor. To clear it so that I can get my x minus 4 to cancel with a factor on top, I have to multiply the numerator by something that will make a match to my x minus 4. That concept is the conjugate. Then, once I multiply by the conjugate, I still have the 2 out front, but the 2 conjugates multiply out to x minus 4, which now gives me my matching factor for the denominator. Cancel it out. I'm looking at the limit as x goes to 4 of 2 over square root of x plus 2. And when we plug in the 4, now that the 0 over 0 is gone, I have 2 over 2 plus 2, which is 4. Slope is 1/2. This represents the slope of function f at 4. Part B, equation of the tangent line. I have my point at 4, 2. My slope at 4 is equal to 1/2. Putting it together, y minus 2 equals slope of 1/2 times x minus 4. This next page is about recognizing the definition of the derivative. My first one matches our format, f of x minus f at a over x minus a. So I'm recognizing the format here matches this format, which gives me the derivative at a. Well, what is the function? The function is found in the top left. My function is the square root function. Where am I finding the slope at? 2 places. I'm looking for the a. So the a is here and the a is here. Both are in agreement. A is equal to 9. The next format is again another recognition. This one is dealing with the slope formula for h going to 0. So that means it's f of x plus h minus f at x all over h. For this one, the function, what you do is you look at what's going on in the top. Most often you can find it from here. I'm taking my input, which is the value of 3 plus a little bit more, and what am I doing to it? I'm cubing it. So I'm saying input is being cubed. If I take an input of 3 and I cube it, I get 27, which is the f of x. So my input value is 3. Take a moment, pause the video, and read through that next example. What you want to do now is you want to type this into your y equals, because we do not yet know the techniques for deriving this particular function, but I can still analyze rates of change using my graphing calculator. I have taken and adjusted the window so it kind of models what we have here on the graph. That's one of your pre-calc skills that you're expected to know how to do, is adjust a window so it can fit a graph. 2 ways to find slope. One way, second calc. Option number 6 is dy dx, which is finding the derivative. I find it at 1, and I have a slope of 30.685. d prime at 1 equals 30.685. The meaning of the slope. At, when, or on. So in this case, it's about talking about the time. So I would say at 1 second, the rate at which the door is opening. If I have a positive amount, it means a positive change. So we're referring to the door opening at 30.685 degrees per second. D prime at 3. In addition to finding slope on a graphical screen, graph screen. You can find slope in the home screen. If you go to the math menu and you go down until you see the derivative feature, which is number 8, it shows you the setup for a derivative. I'm taking the derivative with respect to x. I'm taking the derivative of the function that's in y1, and I want to find it at a value of 3. So this means with respect to, that's the function. This is where I'm finding the derivative. I get negative 26.986. What does that mean? At t equals 3 seconds, the rate at which the door is closing is 26.986 degrees per second. Notice I did not use my negative because my wording is indicating a negative amount. If it's closing, that's what the negative means. So you have to be careful of those scenarios when you have a negative rate. If your wording is indicating something that's negative, you don't put in the negative when you write the amount. Number 13, take a moment, pause, read through it, and then come back. What I want to do is I want to find how fast y is changing at 0.35 seconds. I look at the chart, and 0.35 would land between these two data points right here. I am not going to create a function for y. If you want to find how fast it is changing and you're given a table, then we do approximations. And the approximations are based off of finding slope or rate of change between the y concept and the t concept. So I'd go 7.37 minus 5.84 over 0.4 minus 0.3. So the approximate rate at which y is changing at 0.35 is going to be 15.3. The label is change in y, which is feet, divided by seconds.